Imagine you are building a template class or function in C++. How you ensure that your template class or function is flexible, safe, and works only on valid data types? What if your user provide invalid data types? Hi, my name is Smitesh and welcome to my YouTube channel. In this video, I will show you how to create a safe and error-free template in C++. So let's get started. Before we dive into the SFINAE concept, or substitution failure is not an error concept, we first understand how template works. So consider this code snippet. In the code snippet, there are two methods, multiply method. Both are overloaded. One is for integer data type and one is for double data type. In the main, we are calling for with integer parameter and double parameter, and both method works perfectly. Now, instead of creating individual method for each data type for the same operation, we can create a single generic templated method, and that work for all the data types. So let's create that method. So in the code snippet, I have created this multiply method, templated multiply method. So this is a signature of the template type name T. This is a template data types T. It is a return value, method name, and these are two parameters. Now in the main we are calling with the integer, so multiply integer. Now when we call with the integer data type, compiler in the background first instantiate this template function and template function with integer. So wherever we have a T, it replaces with integer, it substitute with integer and perform this evaluate this operation. Similarly, when we pass with double in the background, compiler instantiate this template function and substitute this template argument with the double. So here we can see double num1 num2 and evaluate this operation. Now when we pass string into the multiply method, the compiler performs the same thing. It creates instance and it substitute template argument with string. So here we have a string, and it tried to evaluate this operation, multiplication operation, but we cannot do string multiplication, and because of this compiler throw an error. So in this example, we can see that here compiler is throwing error here. But what happen if we throw error, or if we do not allow this operation when we trying to substitute this string with template argument? That means when compiler try to create instance of this string, it should check that if it is a string or if it is a valid substitution, then only allowed. If it is invalid, then we should not allow. So this is the concept of the SFINAE, or substitution failure is not an error. So let's discuss what exactly definition of the SFINAE. So what is SFINAE in C++? SFINAE is a feature in C++ template programming. Now it allows the compiler to ignore certain template instantiation when they lead to invalid code. So in this code, in the previous code, we saw that we are passing invalid argument, invalid data type string, and we are performing invalid operation into the multiply method. We cannot do string multiplication, right? So when the compiler instantiate this function, it should ignore this this conversion, or it should throw error, or it should discard this instantiation. So this is the definition of the SFINAE. It allows the compiler to ignore certain template instantiation when they lead to invalid code. So how SFINAE work in the background? So when the compiler tries to instantiate a template, that means when we pass the data type for this template. When we call this template function, in the background it create instance of the function and try to and substitute template argument. So it substitute the template argument into the template definition. If the substitution lead to an invalid type or expression, that means when we pass the string which is invalid, the compiler silently discards this instantiation. Compiler will discard this instantiation because this is invalid, and it try to see is there any valid or viable overload or specialized function that match this requirement. If it is not, then it throw a compilation error. Compilation error here, not here actually. In the earlier code, if we not perform SFINAE compatible template function, it throw here, compiler throw error here, but we want beginning here only, that this is a SFINAE compatible code. So we will see this code also. Now let's see the same code with compatible of the SFINAE requirement here. SFINAE compatible example. So here we are checking. This is the same multiply code. So we are doing templatization. Then we are here checking our type. Type is integer. Then only allowed this method. Here enable if is arithmetic. Here is typing. If it is integer, then only we allowed here. It will go here. If it is not integer or any other data type, string data type, it will not execute here. It will throw an error at here, but not here. This is the concept of the SFINAE. I hope you like this one. Let's see in this the code. This is the same code that I have used in presentation. In this code, first include all the required libraries. Then I have write a template function multiply. It has two parameter num1 and num2, and we are calling this multiply in the main here with the integer argument and double argument, and it works perfectly. So if I run this code, it is displaying this 28.81. So this works perfectly. But when we call with the string argument, compiler is throwing error, does not define operator. Okay. Now we will execute SFINAE compatible code. So this is a SFINAE compatible code. Now you can see here that this is a template, and enable this code when data type is belong to arithmetic operation. Okay, and this is a return value. Here we are returning this t. In this enable if we can return here, so we do not return here t. Instead of that, here we can return. So all the operation will do perform here and return based on this t data type. Now here I am calling multiply with integer and multiply with double, and this run perfectly. Same result, right? Now when we pass string argument, string data type, look here only compiler is not allowing here because it is checking if it is arithmetic kind of data type, then only allows here, otherwise ignore. It throw the error. And this is a SFINAE compatible code. We can check here. Let's see one more example here. I am commenting this. Yeah. Let's comment here also. Yeah, in this code we are adding including require header files. Now this code is belong to the power, means finding the power of base. So we are the first parameter is the base and exponent. That means 2 raised to 3, 4 raised to 2. This kind of function is there. So this is also a SFINAE compatible code. So we are here checking if data type is arithmetic, then only perform this operation here. So in this main, if the power is 2 raised to 3, then it comes here because that is a arithmetic data type, right? Integer data type. So it comes here and execute all the operation and return the result. Similarly for this with double data type. Okay, but when we have a complex number, we have a complex class. I am using that one. When we have a complex number, this is not an arithmetic operation, right? So it will not arithmetic data type. So it will not here. It will come here. We have overload this method. If you see power and power, but here we are using if data type is not arithmetic data type, then call this function here. You can see here not, right? So at that time it calls this power method and return the result. So when we do C and 2, it comes here and execute the operation. This time compiler is not throwing error, but because he found another compatible overload method, and that is the reason it is executing. So let's build and try it. Yeah, we can get the result, correct? Yeah, so this is all about the SFINAE concept. If you like or if you find this video very helpful, please like this video and subscribe my channel. Share with your friend this channel. Thank you.